Okay, so recognizing and naming lattices with cubic unit cells. So let's get some atoms and get to work. Okay, so the first one is if we just have atoms on the corners only, this would be what we call a simple cubic or a primitive cubic type unit cell. So just all 8 corners of the cube all have an atom on them, simple cubic or primitive cubic. Now, disclaimer, technically, and I'm a solid state materials chemist, so I am going to be more pedantic about this than some other people. But technically, the definition of simple cubic or primitive cubic means that those atoms are the same element identity. So this is where I'm going to be like, okay, we're just going to do the ALEKS problem. But I'm looking at this picture that I see right now, and I know ALEKS is going to say that that is a simple cubic. But me, as a solid state chemist, is going to disagree because the presence of blue and silver atoms to me would imply two different atom identities, and I'm not even sure from what they're showing that that would be technically a unit cell because it's not giving the full repetitiveness in 3D space, right? Because if I translated that in 3 dimensions, if we just take that and translate one unit cell over, we're switching identity to blue and silver atoms. So, solid state chemist ran over. I think I'm probably overthinking it, but like I say, I'm very pedantic, so I just want to point that out. Otherwise, I wouldn't be able to live myself, okay? So simple cubic is just all the atoms on the corner. Our next shape, and again, I've just very quickly pre-drawn some unit cells. They're roughly cuboid, but who really cares at this point? It's just to show you. In fact, that doesn't even look like a sphere, but my drawing skills are eh. All right, so if we take that simple cubic and then we have an atom in the center, that is what we call a body-centered cubic. And again, if I'm going to be strict about this, the body-centered cubic lattice would imply that the atom at the center of the body is the same identity as the atom on the corners. Now, sometimes we use these terms loosely just to describe a packing shape, but to be truthful to the definition, that would imply all those atoms are the same element identity, because actually you can have a basic lattice that is simple cubic or body-centered cubic, and then you have other smaller atoms packing in the spaces left in between that packing type. So I'm just being super pedantic about that. Okay, so then the last one then is where we still have our 8 corner atoms, okay? And then instead of having a body center, we have an atom on the center of each face. Now, a cube has 6 faces, right? So I'm going to try and make this as pretty as I can. So top face, bottom face, left face, right face, back face is going to be about here probably, and then front face. So I have to tell you which ones I'm doing because otherwise it just looks kind of ugly. So that is our face-centered cubic. And again, technically, they should be the same atom identity for reasons I've already explained. So if I look at this one right here, I'm going to look and just see that there's 8 corner atoms, nothing else. So I would label that as a simple cubic or a primitive cubic. So I'm just going to zoom through a few of these because I think there's only a few different variations we can see. Again, simple cubic or face-centered cubic. Okay, there is another, different kind of way of asking the same question, which has a slider where you're going to try and choose the image. So this time it's asking about a face-centered cubic structure. So hopefully it will let me pull the slider. Okay, so I would call that simple cubic. This one isn't one of those 3. We've got 4 corner atoms, 2 edge atoms. This one would be a body-centered cubic. This one has something at the body center and 4 corners. This one, we've got all of our corners and we've got 2 face atoms. This is all edges. And again, something like that. As a solid state chemist, I'm going to argue that I could shift the origin of the unit cell and call that a simple cubic. But anyway, we're going to just leave that as it is right now. So again, this would be simple cubic with edge atoms, and this to me looks like a face-centered cubic. Again, the silver and blue, according to the correct definition, should all be the same atom identity. But you can see we've got our 8 corner atoms, and each one of the 6 faces has got atom at the center of it. So I would call that face-centered cubic. Good enough for Gen Chem 1, right? We're just trying to recognize these 3 basic kinds of cubic unit cell types. All right, so that's good enough for now.